Alright guys, welcome back. So unfortunately, the first time I recorded this, the mic was not working. So it's like an hour of content that has no voice over it. So I'm going to try to just kind of whip through this a little bit faster. So basically today what we're going to be doing is Unit 4, which is looping basics and for loops. So as you can see in the background here, I've got Taco Vision going on, and this is an example of a loop, all right, because I've got some condition, which is with Taco Vision is turned on. We're going to keep looping tacos until that variable is broken and that condition ends, and therefore the while loop exits. So anyway, that's going to just be happening in the background here as we're going through. So let's talk a little bit about this. We've seen a while loop, or we've seen loops in the past. Primarily, we've just been working with the while loop thus far. So what we've been doing with this is stuff like Oregon Trail and other games that we've been making. We have something usually is playing is equal to true, and while is playing, do game stuff here, right? So that's been the typical case. We've also been doing some other things like, checking to see that a user has entered valid input, in which case we would do something like while not input, enter your command here. And then, let's see, print like, is not a valid command. And then once we get good input, we say, okay, I'll do that, or that thing now. In which case, so if I ran this right now, basically what's going to happen, so remember we've got this concept of falsy in Python. So if I don't give it anything, if I just hit enter right now, that is a falsy response because it's like an empty string or kind of like null or none. So we're saying that while I don't have input, basically, we're going to print out that was not a valid command, and then we're going to loop back up here, and then we keep doing that until we actually get something. So if I say, hey, says I'll go do that thing now, or in the case of like Oregon Trail, that would have been something like travel, right? Is the command that it was looking for. So yeah, so we've got that in our tool belt of things that we can work with. So typically, we've also been doing stuff where it's like we're accessing single elements in a list, right? So if I have, like my list is 1, 2, 3, 4, 5, 6, right? So there's a bunch of elements in here. And if I want to print all of these out, like we've been doing in some of these exercises, I would say, well, first I would need to make sure I have like a counter, basically, right? So I would have to say like while, let's see, I is less than len of my list, and then len of my list is going to be 6, and so this would be going from, but there's only 5 indices in here because remember this is going to be 0, 1, 2, 3, 4, 5. So len is going to return 6 because that's how many things are in it. So we actually have to subtract, or no, this would be okay because while I is less than 6. So that's cool. So right now what we're going to do then is if I wanted to print all of these, I would have to say my list of I, and then I would have to also, like if I did this is going to be an infinite loop at this point because there's nothing that breaks this because 0 is always going to be less than 6. So I would have to increment this, right? So I would say I is equal to I plus 1, or alternatively, I could say I plus equal 1, which is the shorthand. So if I ran this, and just, here, I'm going to put something down here, like, done. If I run this now, obviously this prints everything out. This is a lot of work to be doing. I had to initialize this guy. I had to come up with this list here. I had to print this out, and I had to pass in what index I'm at, and then I had to keep track of this, otherwise I'm going to get an infinite loop. So that's not great. So let's comment all this stuff out right now. and I'm going to just put this down here. And we're going to introduce something called the for loop. So for loop is a different type of loop, and it works with iterable objects. So the basic syntax here is we'd have for item in iterable, right? Yeah, iterable object. And then we say like do something with item. Okay, so that's a lot to kind of break down here. So let's talk a little bit about what this means. So we've got iterable object. What is that? That is something that we can iterate over. You know, it's not great to be having the definition inside of the word that we're trying, or the word itself inside the definition of the thing that we're trying to figure out. So basically, this is going to be a collection of data that we want to move through. So in this case, like a list would be an iterable object because we want to go through it one thing at a time, where we're pointing at one, then we're moving to the next thing, then we're moving to the next thing, and moving to the next thing until we're done with it. So it can be like a list. String is an example of one of these, because they're kind of like a string would be basically it's a list of characters more or less, in a certain way of thinking about it. And then item is just going to be a temporary variable, basically. So kind of like when you create a function and you have parameters or arguments that you're passing in. That's all that's happening here, right? So we've got, this could be anything I want it to be. I can name this num, I could name this I could name this x. It doesn't matter. It's item is kind of like the meta representation of what this is. But it's just like a temporary variable, and it lives inside this for loop, and then it dies because that's its scope. And it's referencing the current position of our iterator within our iterable. And again, I know this is just throwing a bunch of jargon at you right now, but it's kind of hard to explain otherwise. So our iterator is this thing that is moving through an iterable object one item at a time. So, you know, it's grabbing one, storing that on item, then it would grab two, store that on item, and then you're doing something with that each time. So yeah, it's going to just run through every single item in this collection, and then it kind of just goes away after we're done with it, or after it's done its task. So I'm going to just say for num in my list, so num is going to be my temp variable as we're working through this. And then I can just say print num. And I'm going to get the same result down here. I need to uncomment that though. So if we run this, we see that this is the same thing, only that doing it through a while loop took 4 lines of code and a lot more work, whereas all I needed to do in here is grab num, because the for loop is doing all of that stuff for us, since it's grabbing each one of these items in here, putting it into num, and then we can just work with that directly, and then it does its loop, so we grab the next thing. So yeah, that's the basics of this for loop. So we've saved a lot of we've saved a lot of time because it's less stuff. It was a lot less like dodgy to work with because we didn't have to worry about this condition at all. It just it's going to go to the end of this list and be done. So we don't run into situations where we're going to have maybe an infinite loop. And then we didn't have to worry about actually doing any incrementing. We didn't have to worry about accessing these individual indices. That was all handled for us. So kind of in conjunction with for loops is this other concept we're going to need to talk a little bit about, which are ranges. And they're so closely tied to for loops in Python that I think the documentation even brings them up, or mentions that they are used in conjunction with for loops. So a range is basically just, the definition is not going to help you a whole lot here. It's the is a immutable sequence type. So we would say is if I say range 999, something like that, and we just print this guy out. So it represents the numbers, or like kind of a snippet of a number line from 0 to 999. And there's some oddities around this because the syntax of this is going to be range and then starting point, a stop point, which is exclusive. We'll come back to that. And then there's a step. So those are the three different things. You can even see here PyCharm is giving me in some IntelliSense as it's working through these. So if I want to see what's inside one of these, like, you know, obviously this is the default way that Python prints these out. But we know that it prints lists nicely. And luckily, we can just cast this to a list. So if I run this again, I can see that it started at a default of 0, and it goes all the way to 9999, or 999, but it's exclusive, so it doesn't actually go to 999. It goes to 998. So yeah. And then we can also do things like steps, right? So let's just play around with this. I'm going to say I want this to start at 1. I want this to go to 11 and step by 2. Okay, so I'm going to just print this guy out. And basically what this is saying, I want to start at 1. I want to move by 2 every time that we're creating this range, and go up to 11, which would mean that we're basically going up to 10 because it's 11 exclusive. So in that case, we just get 1, 3, 5, 7, and 9. So there's not a whole lot to ranges. You can do some kind of fancy stuff with the steps, but we'll kind of get to that. If you just create something, if I pass in like 50 here, the default for ranges is going to just be 0 to 50 exclusive, so it would be 0 through 49. And just to kind of prove that, then run this, and there we go. We see 0 through 49 is what Python gives us. So why is this useful for a for loop then? And this is because we can create, like if we wanted something to loop, I don't know, like 20 times, we could say for I in range 20, I think this should be one. We're going to print out I, and since it's going to start at 0, we're going to say I plus 1, okay? And then we're going to run this, and so this prints out 1 through 20 because we're going 0 through 19, because it's 20 exclusive, and then I'm printing these out plus 1. So if I got rid of that, then you would see the actual range of this. So there we go, 0 through 19. So that just lets us loop through things pretty quickly, and that's why it's useful. I don't know, if we wanted to do something like we're going to print out every even number, we could also do things like we're going to start at 2, we're going to go through 31 or something like that, right? And then we're going to step by 2. Here we go. So we started 2, 4, 6, 8, blah, 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 all the way up to 30 because this was 31 exclusive. So that's ranges. They're used like almost always for creating for loops. It can also be used if you just want to create like a list of 1,000 things really quickly for some reason. But that's basically all there is to this. Let me just kind of check through. Oh, I guess there's a couple more things I should talk about here. So let's really quickly then compare and contrast the for loop and the while loop, because at this point in time you might be going like, why would I ever want to use a while loop again? Because that was a lot of extra stuff that you had to do. So I'm going to just kind of create this. We're going to say for loop pros, right? So this is pretty easy to loop over a collection. So it's really good if you want to have, like, if we have a list of stuff and we want to just move through that and make sure we visit each one of them, right? It's harder to cause an infinite loop because these are always, we're working with a finite size loop. Like, you're not going to have like a list with infinite things in it. I mean, there might be ways you can do it in Python. I think most languages, at least most C-based languages, would not let you do that. But theoretically, we could be adding more things to the list, faster than we can actually visit them. Yeah, it's pretty hard in general to cause an infinite loop with for loops. And a lot of the time, it's just that they're shorter and easier to write. So let's talk a little bit then about while loop pros. Okay, so it's easier to loop over more complicated conditions. So I'm going to just put this down. We'll talk about that. So, like, for instance, I don't know, say we want to write a game and we want to have the game in progress until the player loses, they win, or they exit, right? You can't really do that with a for loop because it needs a set sequence. Like, maybe you could do it if your game only allowed for like 10 moves or something, but vast majority of the time you've got this game that can go on for, until something happens, right? Another example is maybe we want to do something until a user enters the right password, and assuming that we're not going to lock them out after like 3 improper guesses. That may be an example of somewhere where you'd use a while loop with a kind of complicated condition that a for loop couldn't handle. So basically, they are generally going to be more powerful. I mean, like, at least in Python, they can do everything that a for loop can. Plus more. No. But, it's at a cost because they're a little bit more complicated to work with. There's a lot of errors that they can cause. And there's certain things that are just kind of like annoying to do with them. But in general, they're going to be doing a lot more than a for loop can. The other thing I want to talk about real briefly here, I don't know where this actually is going to get touched on otherwise, is a keyword called break. So this is something that gets kind of used in conjunction with lists. Basically what this says is it's kind of like the return statement in a certain way, in that as soon as you use the break keyword, it'll basically eject you out of a loop. There's other places that it gets used too, but since we're talking about loops, we'll talk about it here. So let's say, like, I don't know. Let's say like I have for x in range, and I'm going to put something huge in here, right? So the way that this would work is I can say we're going to print x first of all, and then what do I want to be doing after that is I'll say if x equals 3, we're going to break. And then just to kind of show that we broke out, I'm going to put this here. So normally what this would do is we're going to be going from 0 to whatever this number is. It's huge, right? But when we run this, it actually only prints 0 through 3, because once x hits 3, it breaks out, which means that we kind of just get out of this entire for loop, and we go to this next line. So this gets used as well in, like, I don't know, if we wanted, let's see, like if we had something like while true, command is equal to input, type exit to exit or something like that. We'll put the little space there, and then let's say like if command is equal to exit, we could say break. Otherwise, it's going to infinite loop because like while true is an infinite loop, inherently an infinite loop. There's no way to get out of this otherwise. We need something that would hard set to get out of here. So I'm gonna just keep saying things, right? So I'm just gonna type in a bunch of stuff. I'm gonna type in exit. This ends, and we see that this thing finishes with exit code 0. That means it completed successfully. So yeah, that's the break keyword. So yeah, we're going to just kind of move on then into kind of the core parts here of the lesson, which is going to be these in-class exercises. So out in REPL, you should have a single assignment, and it's got 7 problems to work through. So we're going to open this guy up to this first one. So question 1 is basically just we're going to create a list of numbers from 0 through 999, then print the numbers out one per line with parentheses around them using a while loop. So this is kind of just to get used to the idea of like we've got the while loop, and we're going to kind of compare and contrast how easy this task is with one versus the other. So how do we do this with a while loop? So first off, we're going to have to use ranges in here because this is an enormous amount. We don't want to be sitting here saying like my list is equal to 1, 2, 3, 4, 5, blah, blah, all the way up through 1,000, right? There would be 1,000 numbers that we have to type. So let's just call this list 1,000 nums. And we're going to set it to a list, and because lists are, or we can create lists out of ranges, we're going to just say range 1,000 because remember, this is going to be creating a range from 0 to 1,000, but it is 1,000 exclusive, which means it goes up to 999. So now we've got this first part done. We've got a list of numbers from 0 through 999. Now what we need to be doing is printing all these out in this specific way. So with a while loop, we need some sort of condition, and we want this to loop a specific amount of times. So typically you do this with a counter of some sort. So we're going to use I. I is the typical counter that you'd be using. And we say while I is less than, we'll go len, because this, we could say is less than, 9, or less than, 1,000, because that would be the last index. But to make this a little bit more generic and dynamic, we could say len of 1,000 nums. So we now have our conditional because the len of this is going to be 1,000, and this is going to go from index 0 through 999, which would be the 1,000th index since you're starting at 0. So while this, and then we're going to just print this out, right? So we need to grab the thing at that particular index. Oops. So grabbing thing at the current index, and then again, because this is a while loop and we're using our own counter for this, we need to make sure that I gets incremented somewhere, otherwise this condition is never going to be met and the while loop will never end. So we're going to say y, or I plus equal 1. There we go. And so if I run this right now, I should also kind of hark back to this. So remember, when we were creating functions, def is the keyword for define, basically. We're going to define this function print 1,000 list with while loop. We've got 2 parentheses here signifying that this is a function, and then we have a colon here saying that we're going to be starting our function block. And then all these guys are indented, and then we have even further indentation when we're getting inside a while loop, because that signifies that this stuff is inside the while loop, whereas this part is in the function, right? So now that we've got all this done, if I just ran this, this isn't going to do anything because I haven't actually called this function. So if I go down here, I can say print 1,000 list with while loop, parentheses, which means that I'm going to call this function now. Because otherwise Python's going to be running through this. All this stuff is commented out, so there's nothing for it to do here. Here it's define, and basically it knows now that this code or this like identifier lives here, but doesn't need to do anything with it. And here's something in the global scope as Python is running through this script line by line, and it goes, oh, okay, I need to call this. So it puts this function onto the call stack, goes up here, and processes all of this stuff, returns, which pops this off of the call stack, and then does its thing. So let's run this and make sure that this works as intended. So here we go, printed out 0 through 999. But what I didn't do is get this piece here with the parentheses. So there's a bunch of different ways we could do this. We could use f strings, we could use .format, we can use commas in here as separators. I'm going to just use string concatenation though, because it's just pretty simple. Whoops. So I'm going to put this guy in here, and then plus, and now this is also going to, if I run this right now, this is going to throw an error, or it should. Yep. And this threw an error because this must be a string, not an int. Remember, this is going to be a list of integers, so I need to convert this to a string before I can actually do anything here. So run this again, and now our output looks the way that we want it to. That's great. So this one is actually done. So now we're in this in-class exercise 2. We are basically doing the same thing, but we're going to do it with a for loop this time. So kind of the same idea here. We're going to have this list called 1000 nums, and then we're going to make a list from a range, and we're going to put 1000 in here, right? So we've got that piece done, and now instead of having to do all this extra junk, we can just say for num in 1000 nums, and I'm using tab to autocomplete that. It's something that most IDEs do. I think REPL does it as well. So for num in 1000 nums, now we're going to print this out. And again, we're going to have to put some parentheses around this. Again, I'm going to use string concatenation just because that's going to kind of highlight the differences between these two. There we go. So we did this, and again, since this is a function, I'm going to need to call it somewhere. So let's run this, and we see that this is indeed printing the same thing out, and it's a lot less lines. So here we're just kind of, well, these are going to be different text sizes anyway, but you can see this is a lot more lines, and there was a lot more thinking that we had to do in order to get this to do the same simple task. So there we go. Let's move on to this next question here. So question 3 is we want to complete the function below so that it returns the input string with no vowels. So this is getting a little bit more complicated, right? So what the idea here is going to be that we can move through strings because they are also iterable objects. So what we want to be doing, basically, if we're going to talk high-level algorithm, is we want to say, okay, for each letter in here, we're going to look at it, and we want to see, is it a vowel? If so, we want to chuck, throw it out. If it's not, we're going to keep it. So let's see here. So first thing we want to do is we need to figure out how we're going to move through this. So what we can do is say that for character in a string, so this is going to now be moving through, and each time, so like the very first iteration of this loop would be like in this example here, we've got 2 different strings that can be used for kind of testing your own code. This very first one, we have t would come in on character because we're passing this string in. So this string gets passed in to a string, so that's what its value would be. And then for each character in a string, we're going to look at it and do something. So one way that we could do this is we can say, if character is equal to A or something, or character equal to E, and so on. That's one way. We could just have a giant if statement. If it's any of these guys, we would basically skip over it. In which case we might want to say, like, if character is not each one of these, and character is not equal to that, blah, blah, blah. I'm going to show you another way that we can do this, though, that'll make this a little bit easier. So I'm going to define a list here, and I'm going to call it vowels, and I'm going to load it up with all the vowels. E, I, O, U, and sometimes Y, because, whoops, because Y deserves a little bit of credit here. So what we can do now is actually, we're going to be able to use this in keyword, because we can check to see if something exists in a list, which is, we're going to kind of get into this in the next unit, or part of this unit, but it's almost like doing a loop within a loop. So what we could say is if character or char is not in vowels, now we need to figure out what we're going to do here. So what I like to do in some of these is I'm going to start out with a result and initialize it to a blank string. And then we know at the very end of this we need to have a return, and we're going to return the result. So if character is not in this list, then we're going to basically add it to the results. Otherwise, we're going to skip over it. So we'd say result plus equals character. I'll get to this in a sec here. We're going to comment this guy out, and we're going to try running this again, or running this for the first time. So as we see here, this successfully removed all the vowels. What this doesn't account for, though, is, let's say this guy had caps lock on randomly, or was just holding shift or something, and now we have a capital E. So if I ran this now, this actually leaves in the E because there's case sensitivity. So capital E was not in this list. There was a lowercase e there, but Python isn't going to recognize those as the same thing. So a common way that we approach this, instead of, we could duplicate this entire list and put all the capital letters in there, but it's a lot of work that we don't want to be doing. So what we can do is just say dot lower, which takes any character that comes in, temporarily makes it lowercase, and then we can check to see if the lowercase version of that letter exists in vowels. So again, if I'm going to run this, now we're back to the correct thing being output. So in here, there's also this second one. And the idea here basically is this string is so long that you would never even attempt to hard code it, whereas this one's small enough where you could theoretically hard code it, right, if you wanted to just kind of cheat the system. This one is so big that you're going to want to use a program to do it because it's annoying. So in this text here, so this is, if you Google lorem ipsum, this is just a kind of like generic text that you get a lot in programming. And it's used to kind of like, it's a lot during like web development. So like if you were creating a blog or something and you created this great layout and you wanted to see how it actually looked, but you didn't have any blog posts written, you just go to lorem ipsum generators. They give you this giant chunk of Latin, and you can dump that into your website and just kind of make sure that everything's lining up correctly and it looks good with some bogus filler text. So that's all that's going on with this. And this also just gives you another test case to run, right? So I'm gonna run this guy, and here we go. We see that it did successfully remove all the vowels from that. So there we go. That is how you solve question 3. Just here on time. All right, so let's go on to question 4. So this one is asking us to write a function that A prints out even numbers from 1 to whatever max num is, stores those numbers in a list, and then returns that list. Cool. So again, we've got a function given to us, or a function header. This is kind of like prototyped or stubbed, or there's a lot of different ways that you could say this. So we've got the function definition keyword, even number list, and this one takes in one parameter or argument, which is called max num. And right now, again, we've got this pass keyword here, which just means that it allows the function to be defined but not have any contents. So if I try to remove that, Python would get mad and say like, yo, you need to have some sort of, it's expecting an indent is the error that it throws here. Because Python needs functions to have some sort of content. So when you put pass in here, it just says, all right, we have, this is a valid function. We haven't done or created it yet, basically. Just pass over it for now. So anyway, let's talk about this guy. So what we want to do is find all the even numbers from 1 to max number. So let's figure that out first. So very easy approach here then might be to do something like, let's say for num in range max num. And of course, we're going to need to add 1 here because that's an exclusive. So, if I threw 10 in here as the max number and wanted to go through 0 through 10, I would need to go actually up to 11 because 11 would be excluded and 10 would be included. So let's see how this works here. So basically, remember we're going to be using probably modulus for this. If we do if num mod 2 is equal to 0, that would let us see whether or not this is a even number. We could say print num. So just let's try this out first and see if we have this first piece working. Oh, right. So I didn't actually call this. So let's throw 10 in here because we know what 10 should do. So this is not working correctly just yet. This is starting at 0. So what we need to be doing then is telling this to start specifically at 1 and go up to max num plus 1. So let's try running this again. And now we're seeing the right things printed out. We've got 2, 4, 6, 8, 10. Great. But now this isn't storing those in a list anywhere. So how do we do that? First thing we want to be doing, well, let's call this list result. That's what I like to call these. We're going to initialize this to a empty list, which is just 2 brackets. And then what we're going to do is we print this out here, and since we're printing it, what we also want to do then is say result.append num. So that's going to just put it onto the end of the list. All right, and then at the very end of this function, we just want to return result. And let's see how this works, or just to kind of show that this works. So I'm going to say temp is equal to this, which means that whatever this resulting list is going to get returned and stored into temp. And so I should be able to print temp at the very end. And there we go. We see a list getting returned and printed out with 2, 4, 6, 8, and 10. So that's great. That's a lot of stuff, though. Let's see, is there a easier way that we could do this? So what we know is that ranges also have this step parameter. And we can just say things like, we want to step by 2, which means that in this case, we don't need to, if I ran this right now, right, so theoretically we want to be able to get rid of this line because we're going to be stepping by 2. I'm going to change the indentation here so that these things are line up correctly. If I ran this now, this is going to be actually giving me every odd number. And there we go. That's as expected. So we just need to be careful about this. And since this one doesn't want us to start at 0, the very first even number that this should be seeing is 2. So we would change this to 2. And now we can just run this. And there we go. So it's two different ways that we can solve this with like a slight optimization potentially. I don't know which one's actually faster for Python to do, but this is less code. All right, so let's move on to question 5 here. So this one is asking us to simulate a countdown from a starting point using a for loop. So an example here is if we gave it 10 as the starting point, it would say 10, 9, 8, 7, 6, like all the way to 0. It's going to store these numbers in a list that gets returned. Okay, so we know how to count forward. Is that going to be helpful here? Maybe. So let's try this. We're going to bust out our for loop again. Well, before that, we know this has to return a list. So we're going to say we're going to just kind of get that out of the way first. Okay, now we're going to tackle our for loop. I'll just make this a little bit bigger. So let's just make this count forward right now. We'll use a different thing here. So we'll go for x in range starting point. Okay, and we need to have +1 there, so that's the correct size. And let's just print x. Okay, so this isn't going to be doing what we want it to, but that doesn't matter right now because we're just going to be testing this little by little. And then we got to call this. So I'm going to run this guy here, and we see that we are going 0 through 10. So this is good. It's just not in the right order. So how can we modify this to be in the right order? What we could do is basically say 10 minus x, because x is going to start at 0, so then it would be printing 10 minus 0, which would be 10. When it goes through the second loop, it would say x is 1, so it would be 10 minus 1, which would be 9. So let's just run this. And now this is working correctly. However, this part is hard-coded. So if all of a sudden I go, I want 20 in here, now this is busted, right? Because this is not the countdown that we were looking for. So what we need to do is say starting point minus x, because that makes it dynamic. And now this is working correctly again. So again, we can just use append. We could say result.append, and we need this entire thing to go inside here. And then we're going to return that result. And again, I'm going to put this into temp. And then let's just print temp out to verify that we have the correct result in there. Okay? So cool, this looks like it's working. But is there another way that we could be doing this? So there is a separate way that we can make this work. And very similar to this, where we're using steps, we could also be using steps here. So in this one, what we actually want to be doing is starting at, not starting point +1, but starting point, because this would be 10. And remember that the starting point of a range is going to be inclusive. And so we'd want to go down to 0, and this is actually going to be a problem here, but we're going to talk about that in a second. And what we can do is, remember in this other example, we were stepping by 2 to make it grab every even. In this one, we can tell it to step by -1, similar to how you might do like a slice. And now it's walking backwards through this range of numbers. So instead now, we don't need to be doing all this fancy stuff. We can just say print x, and then we can append it. But again, we're going to run into an issue here. So let's run this guy, And this is good, but it doesn't go down to 0. So we never get like the blast off moment, right? So what we want to do is, because this second parameter is always going to be exclusive, we need to tell it to count backwards from whatever starting point we give it by -1. So each time it's counting down. And then it goes to -1 exclusive, which means that it would go up to -1 but not including it, which makes it the last thing it visits is going to be 0. So there we go. 2 ways to solve this countdown question. Right, moving on, we've got question 6 here. So this one's a very common interview question, like especially if you're going for like an entry-level position. So we're going to just write a function that will reverse a string. And you can do this very trivially with slices, and there's, a lot of languages have built-in functions to handle this. For this, because we're working on loops, we want to be using a for loop for this. So how do we approach this guy? So first off, let's figure out like what we would want to give this, right? So we're going to end up passing this something like hello, right? And theoretically, this is going to return hola. So the reverse of that. So we know that we can do things like walking through a string, right? So we could say for car in input string, and we could use things, all kinds of, like, I think I forgot to show this in this taping of this video. Right now, we could just kind of explode this guy, right? So we can do these things like we're revisiting each character at a time, but that's not very useful for us right now. So let's just print this out. So we are printing, or we're able to visit this string going forwards. So what do we want to do here? So we could do this by, let's see. What happens if we just take these, so we'd grab H first, and then if we put that on the string, and then we grab E and put that in front. So what that would look like then is, let's create a result here, and we're going to return this guy, right? Cool. So yeah, we've got this blank string, and what we're going to do here is I'm going to say result is equal to char plus result. So what this would be doing then is that as we're looping through, we grab H, we put it here, and then store that entire thing back into result. So result would be H at this point. Now we're going to move to the next letter in here, which is E. And then we're going to put E in front of result, and right now our result has H in it. And then store that entire thing into result. And then again, we're going to go through, and this time we are fetching the L, and we put that in front of result. So let's say here, we're going to say temp is equal to that, and then we're going to print temp just because this is easier to see, kind of understand what's going on. So this worked as we wanted it to. Is there another way that we could do this, though? And the answer is going to be yes. So strings can also be indexed, right? So I could say something like, all right, let me just comment this entire guy out. So I could say something like, if I have hello, and then I can put in index 2, and let me run this guy. And so that prints out L because this would be index 1 or 0. Index 1 would be the E, and then index 2 would be this first L. So you can do that. And the reason that this is, The reason that this is helpful here is because we could say something like I in range, then we'd want the length of our input string, which would be, if we were giving it hello, the length would be 5. But we want this, so what we want to do is basically do one of these ranges where we're walking backwards and grabbing those indices. So we just want to start at index 4, which would be the last character here, and then walk backwards until we get to index 0, and each time we're going to be going by -1. So we could say we're going to go to len -1 basically, because that's going to be 4. And then again, remember we have to put in -1 because it's the second parameter that we give this is exclusive. So if we want this to go to index 0, we actually have to throw in -1 so that that's the place that it stops exclusively. And then we want this moving by -1 each time. And instead of doing this now, because we are grabbing the last character and moving backwards, we can just say result plus equal, we're going to say input string, and then give it an index of I. Okay. So let's run this guy. And oh, we're not printing this, so we got to print temp at the end. So what happened here? So we've got a range, and this range, if I do this, if I just print the list version of this range out, we get 4, 3, 2, 1, 0, which are all the indices here, but in reverse order. So because this is moving backwards, so we have, when the first loop here, I is going to have 4 in it, and so we're fetching the 4th index, grabbing O. The second loop is going to grab this E, or the 3 rather, so it's going to grab this L in particular. So this is two different ways. This one's a little bit more complicated to think about, whereas the other approach is a little bit more straightforward. But just to kind of show off all the different things that you can do with for loops and ranges. All right, so let's move on to this very last one. And question 7 is, how do we write a function that pluralizes words that take, or so it's going to take any list of words, and we can see down here an example. We got word list, and it's got apple, berry, and melon. Okay, and then it doesn't return anything, so we don't have to worry about that. We're going to make plurals we're going to make plurals out of these with basically a dumbed down version of how English would handle this. So if the word ends in a Y, we're going to remove that Y and add IES. So in this case, we would have, instead of berry, we'd have berries. Otherwise, we're adding an S to the end. So we would have apples and melons. So yeah, this one's going to be a little bit more complicated to think about, right? So we're getting in a list of strings is the first thing that we need to think about. And it's also updating all of these values. And remember, lists are mutable objects, which means that they're created once and we have a reference to that. So if I do pass in something like a word list here, it's going to come in on input word list, and that's going to be modified directly there because they're pointing at the same location in memory. Whereas immutable objects like integers, in Python strings are immutable. Most languages they aren't. Those are passed by value, which means that anything that you do to them in the function wouldn't be maintained outside of it. So that's what means, or what this is saying, is that we're going to update these values in place, basically. Okay, so that's a lot to kind of take apart here. So what we want to be doing first off is we need to figure out how we can move through this list of potentially like hundreds of words, right? Um, so in this case, we're going to just start out by saying for word in input word list. And now, so lists are iterable objects. Uh, but unlike the other examples where we've been working with a string as an iterable object, or a range or something where it's like integers, um, this is entire strings because this is each bucket inside this list has a full string. So when I iterate through this, the very first time I grab something out of here, word is going to be apple. And then the second loop through, it's going to grab berry and put that into word, and so on. Um, so now we've got apple to work with basically, and we want to look at this and basically look at it. Does this end in y? And that poses another problem for us. So how do we figure out what the last letter is? And remember that strings are kind of like lists by themselves. So I can just say something like word, and we don't know how long this word is. Like, oh, these guys are the same letter or same amount of letters, but we would need to say something like len of word, which in these cases, this is going to be 5. And remember, the last index here is going to be 4. So what we need to do is account for that and subtract 1. Of course, this is going to be an if statement because we need to check, is this last letter y? So at that point, we can just say, if the last letter is y, then what we want to do is we're going to be modifying this in place. So let's first work through this in kind of the way that's not going to work. So we would say something like word and is equal to, what we want to do is grab all the letters up until that last one, which would be y. And one way that we can do this is with slices. So we could say word, and we want to start at the 0th index and move from len of the word, which would be 5. Let's see, maybe -1 they want. Should be, oh yeah, because remember that a slice is going to be inclusive of the 0th index, so it would be including a, go all the way up to len of word -1, which would be 4 in this case, but it wouldn't include it, so we'd get apple without the e, which is exactly what we want. And we could say plus IES. Or, yeah, but this one's not. So we'd have berries in this case. Otherwise, and we want to have some control logic here, if it doesn't end in y, we want to just put an s on the end. That makes me think of something else here. I don't know what this is. I'm going to get rid of that. Okay. So we're going to say here then is, we could say word is equal to word plus s. Pretty simple. Cool. So let's run this right now and see what happens. And we see that both of these print out the same. And that's because we're modifying word, which is a temp variable. So we did some work with it and then it disappeared. We didn't store it anywhere. Whereas this input list is something that actually has stuff in it that we're working with, or that we want to modify. So we're going to actually kind of combine two techniques here. So I'm going to start this as I is equal to 0, because we're going to be working through the indices. And what we want to overwrite is not word, but the thing, or the place in this iterable object that we were actually at. So I'm going to put in here I. And then we're going to do the same thing down here. So basically now this is saying that, we're going to grab apples. And so apples is be index 0, or apple is the index 0. We're going to theoretically, we should be able to say, okay, is this going to be equal to y? No. So we go down to the second case. And then, of course, since we are trying to move through this entire thing, we want to be doing I plus equal 1. Okay? And because this is mutable, we don't actually need to return anything. We're modifying this guy live, basically. And now we actually see the correct result down here. So great, this approach works. Now, one thing that's kind of interesting here is that we notice both of these end in S. So we have an opportunity here to actually reduce the code even further because they both do the same thing. So what happens if we got rid of that else and we're adding S to the end, and then because this is a special case, we can actually get rid of this S. So let's run this guy. Oh, you know what this is? I know what the issue here is that we want to be doing this guy plus that. There we go. So in the event that this is a y at the end, we chopped it off, added IE to this, and because both of these cases end in S, we can just modify this entire thing since it got stored back into our list and put S on the end. So this is like a slightly more optimized version of this. Could also do this with a while loop, but we're kind of already at, over an hour right now, so I think that should be enough for today. Hope you guys are all doing good, and I will be putting out another video pretty soon to kind of wrap up loops. All right, see you guys.